So in the last video, I gave you an introduction to exponents, and in today's video, we will be doing some review questions, then moving on to power laws. So in our first question, we have negative 3 and this negative 2 exponent. So if you remember from last time, we have our negative sign, which tells us that we must multiply this product by negative 1. And we have our negative exponent, which tells us to take the reciprocal of 3 to the negative 2. So we have negative 1 times 1 over 3 squared, which is negative 1 times 1 over 9, and that gives us negative 1 over 9. And again, if you're not comfortable, if you're finding difficulty with this negative sign here, if it's hard for you to understand, remember it's just the same thing as negative 1 times 1 over 3 squared. So in our next example, we have 4 over 4 to the negative 1 plus 4 to the 0. So that will give you 4 over. So if we remember, we have our negative exponent, so we have to take our reciprocal once again. And we have our 0 exponent here. So anything that is raised to the power of 0 except 0 is 1. So our denominator now will be 1 over 4 to the 1, which is 1 over 4, plus 1. And that gives us 4 over, and 1/4 plus 1 is 5 over 4. So now since we're dividing we're dividing a fraction, we have to take our reciprocal and multiply. So that's 4 times 4 over 5, which is 16 over 5. And in our last example, we have this time 7 over 2, and this will be raised to the negative 2. So that gives us 1 over 7 over 2 squared, which equals 1 over, so it's 7 over 2 times 7 over 2, which is 1 over 49 over 4. And that gives us, so since we're dividing, it's just like here, dividing a fraction, we have to take the reciprocal of this fraction. So that's 1 times 4 over 49, which equals 4 over 49. So now we're going to be looking at power laws. And power laws basically tell us how we can multiply exponents or how we can divide exponents. And there are 3 power laws when we are dealing with exponents. The first power law is about how to multiply powers that have the same base. So in our first power law, we have x to the m, and let's multiply this by x to the n. So this is kind of the general rule for our first power law. as you can see in this power law, we have two different exponents, m and n, but we have the same base, x. So what this tells us is that when we multiply exponents, when we multiply powers that have the same base, we must add the exponents. So this becomes x time to the m plus n. So if I give you an example, let's say we had 3 to the 4 times 3 to the 3. So from our power law, we have the same base, 3, and we have different exponents, 4 and 3. So what we have to do is we have to add the exponents together. So it's 3 to the 4 plus 3, which is 3 to the 7. And this works because if we write this out, we have 3 times 3 times 3 times 3. So that's 3 to the 4. And then for 3 to the 3, we have 3 times 3 times 3. So if we count, we have 1, 2, 3, 4, 5, 6, 7 threes, and that's why we get 3 to the 7. So in summary, when we have powers with the same base, we have to multiply, and we're multiplying these powers. We can't add them, we can't subtract them, we're multiplying them. We have to add our exponents. And this works because if we write these powers in expanded form, we're basically just counting how many bases we have, and that gives us our final product. So with our second power law, we are going to be dividing powers that have the same base. So if you look at our general rule again, we have x to the m and dividing that by x to the n. So with this power law, we're going to be subtracting our exponents, and this works as long as we have the same base. So we have x, and then this will be raised to the power of m minus n. So if we take an example, let's say we have 4 to the 4, and we're dividing this by 4 squared. So we have the same base, which is 4, and our exponents are 4 and 2. So that gives us 4 as our base, and we're subtracting these just like we did here. So that's 4 to the 4 minus 2, and that gives us 4 to the 2. So if we look at why this works, we have to write these powers out in expanded form, just like we did with our first power law. So we have 4 times 4 times 4. And we have our 4 fours just like 4, which gives us 4 to the 4. And then we have 4 times 4, which is 4 squared. So we know that we have a lot of 4s on our numerator and our denominator, and since we're multiplying these 4s, we can cancel them out. So these 4s cancel out, and these 4s cancel out. So we have 4 and 4, which is 4 times 4, which is 4 squared. So to sum this all up, when we're dividing powers that have the same base, we subtract their exponents. Remember, this only works when we're dividing and we have the same, we have powers that have the same base, just like here, x and 4 and 4. And again, this works because when we put our powers out in expanded form, we're basically just canceling out the bases to get our product. So with our last power law, our exponent will be outside our brackets, and inside these brackets, there will be a power. in our basic rule or general rule, this will be represented by x to the m, and this will be raised to the power of n. So our product will be x to the m times n. So basically, when we have our exponent outside the bracket and inside the bracket we have this power, we have to multiply our two exponents, just like we did here, m and n. And if we look at an example, let's say we have 5 squared, and we cube this. We raise this to the power of 3. So we have our two exponents, 2 and 3, just like we had exponents m and n. So we are going to be multiplying them. So that gives us 5, and raised to 2 times 3, which is 5 to the 6. And to understand why this works, we have to write this out in expanded form. So that gives us 5 squared times 5 squared times 5 squared. And to further expand this, it's actually just like what we did with our first power law. We have to expand each 5 squared. So that gives us 5 times 5 times 5 times 5 times 5. And if you count the number of 5s, we have 5, 1, 2, 3, 4, 5, 6. So that's 5 raised to 6. So to sum this up, if we have an exponent outside the bracket and inside the bracket there's a power, we must multiply our exponents. And if we want to further understand why this works, we have to write this out in expanded form. So we can actually use this power law when we have uh, two powers that are being multiplied together inside a bracket, or even divided inside a bracket, and there's an exponent outside the bracket. So if we look at an example, let's say we have these two variables. Let's say we use variables and we have a times b, and we square this. And then we also have a divided by b, and we square this. So if we think back to our exponents, this is basically a to the 1, and this is b to the 1. So what we have to do is we have to multiply our exponents by whatever our exponent is outside the bracket, just like we did here. So that becomes a and to the 1 times 2, which is a squared, times b squared. The same applies here. So we have a to the 1 and b to the 1. So that becomes a squared, because 1 times 2 is 2, and we have b to the 1 times 2, which is b squared. So a common mistake that is made is that if someone writes out, if we have a plus b squared, or if we have a minus b squared, what may happen is you may automatically think, oh, we have to multiply each, or we have to raise each variable a and b to the 2. But actually, this is incorrect. We can't say a squared plus b squared and put here a squared minus b squared. These two are incorrect. a plus b squared and a minus b squared is completely different from a times b and a over b. So remember that we only want to use this specific power law if one here we have a power inside the brackets and an exponent outside the brackets, or here we're multiplying our powers and we have our exponent outside the bracket, or if we're dividing our powers or variables and we have our exponent outside the bracket. Not when we're adding variables or powers or subtracting variables and powers and we have this exponent outside our bracket. It's completely different. So I hope you enjoyed today's video and learn about power laws. In our next video, we will be looking at a lot of examples on this topic, and we will also be moving on to variables and coefficients. So if you have any questions, please leave them in the comment section below and stay tuned for the next videos. Thank you.